Hello everyone. Today we will discuss about AC circuit analysis. In our previous discussion we discussed about DC circuits analysis with the help of different type of theorems and its concept. Now let's understand our AC circuit concept. First we understand what is AC circuit analysis. AC circuit consists of circuit elements such as resistor, inductor and capacitor and also contain AC source that may be a voltage source or current source and to find the responses in a circuit elements. Now presentation of AC quantities, why do we need phasors? If you consider a sinusoidal voltage V is equals to Vm sin omega t that is varying with time and it has angular frequency omega, and when we apply this sinusoidal voltage in any circuit which contains circuit elements resistor, inductor and capacitor, for which to find the responses in the elements we have to apply some laws that are Kirchhoff's law. So for the applying the Kirchhoff's law we have to add these quantities or subtract these quantities. These quantities are given in the instantaneous form. So for the instantaneous form the addition and subtractions are quite difficult. So for understanding the concept of alternating quantities, we need phasor representation for such type of waveforms. Now understand the concept of phasor, for which we consider two voltage waveforms. Our first waveform V1 is Vm1 sin omega t and second waveform is Vm2 sin omega t minus phi. If you analyze the waveform shape, this V1 waveform will be like this. It starts from omega t is equals to 0 and its maximum value is Vm1. And if you analyze the waveform shape V2, it starts from angle omega t is equals to phi. This is angle phi and its maximum amplitude is Vm2. So here we can see the amplitude and angle. If you understand the concept of phase angle, then we can easily make our phasor. The concept of phase angle states that it is the angle which makes from the reference line. For the voltage waveform V1, omega t is equals to 0 is our reference point. So this 0 degree is defined as phase angle. In the waveform 2, if you consider this omega t is equals to 0 is our reference point. So for this waveform, this 0 degree is the phase angle. And if you consider the voltage waveform V2, the phase angle is minus phi. So this is the concept of phase angle, the angle which makes from reference point. The voltage waveform V2 attains its maximum value after angle phi. Now, for the phasor representation, we need two quantities. For the phasor, first is magnitude and next quantity is phase angle. So here we understand the concept of phase angle. The first wave, for the first waveform our magnitude is Vm1 and for second waveform magnitude is Vm2. And phase angle for the first waveform it's 0 degree and for the second waveform it is minus phi, which is making from reference point. For the phasor representation of these waveform, if you analyze, for the first waveform it is at 0 degree, its amplitude is Vm1 at 0 degree. And if you analyze the waveform 2, this is our 0 axis line and its phase angle is minus phi. So make the phasor with angle phi and amplitude is Vm2. So this is the phasor representation of these two voltage waveforms. If you understand the concept of phase angle, then we can analyze the phase difference. Here we consider two voltage waveforms. First voltage V1 is Vm1 sine of omega t, and our next voltage V2 is Vm2 sine of omega t minus phi. Both the waveforms having same frequency, so we can analyze in single phasor. First voltage waveform having phase angle 0, so it is represented at 0 degree axis having magnitude Vm1. Second waveform having phase angle minus phi in clockwise direction having magnitude Vm2. If you analyze these two waveform having phase differences phi. Phase difference is basically the difference between the phase angle of two waves. Now consider if phase angle phi is equals to 0, then V1 is equals to Vm1 sine omega t and V2 is equals to Vm2 sine omega t. So the phasor representation will be like this. This is Vm1 for voltage V1 and this is Vm2 for voltage V2. Both the waveform having 0 phase angle. This phasor representation said that in same phase, both the phasor in same phase. And if you analyze the phase difference between these two phasors is 0 degree. Now consider concept of phasor in terms of leading and lagging. Here we consider two voltage waveforms. V1 is Vm sin omega t, V2 is Vm sin omega t minus phi. Now analyze its phasor. First voltage waveform V1 having phase angle 0 degree. So it represented at 0 degree with magnitude Vm. Second waveform having phase angle minus phi is clockwise direction and its magnitude is Vm. Now analyze the concept of lagging and leading. There is one waveform ahead and other waveform is behind. For this concept, we take one waveform as a reference waveform. If you analyze the V1 voltage as a reference, then we can say the voltage waveform V2 is behind, or you can say it is lagging. V2 is lagging by angle phi with respect of V1. And if you analyze the voltage waveform V1 with respect of V2, you can say the voltage waveform V1 is ahead of V2, or you can say V1 is leading by angle phi with respect to V2. So when we say lagging or leading, we have to take one waveform as a reference waveform. Then we take another example to understand leading and lagging concept. Here we consider three voltage waveforms. V1 is Vm sin omega t, V2 is Vm sin omega t minus phi 2, V3 is Vm sin omega t plus phi 3. Now analyze phasor as all the waveform having same frequency. V1 waveform having phase angle 0 degree, it is represented at 0 degree. V2 waveform having phase angle minus phi 2, minus phi 2 in clockwise direction. It is minus phi 2 having magnitude Vm. Now consider the V3 waveform having phase angle plus phi 3 in the counterclockwise direction having magnitude Vm. So here we can analyze this concept leading and lagging by taking one waveform as a reference waveform. If you analyze the waveform V2 and V3 with respect of V1, we can say, if you see the V3 waveform with respect of V1, V3 is ahead. So you can say V3 is leading by angle phi 3 with respect to V1. And if you analyze V2, V2 is behind the V1. So you can say V2 is lagging by angle phi 2 with respect to V1. If you take V2 waveform as a reference, then we can analyze the waveform V1 and V3. If you analyze V1 waveform with respect of V2, V1 is basically ahead. So you can say the waveform V1 is leading by angle phi 2 with respect to V2. Now analyze V3. You can say this V3 waveform is also ahead with respect of V2. So we can say V3 is leading by angle phi 2 plus phi 3 with respect to V2. So we can understand that leading and lagging concept attain by taking one as waveform as a reference waveform.